Very good morning, student. Today we are taking new chapter, that is the circle. So we see here different properties of the circle. What is the circle? As you already know, as you in 9th class also learned about the different properties of the circle. As you know that circle is a collection of points. So if you want to say circle is a collection of all points in the plane. Circle is the collection of all the points in a plane which are at a distance from a fixed point, which are at a distance, that is constant distance. You can say constant distance from a fixed point. Clear? So this is the definition of a circle. It is a collection of all points in the plane which are constant distance from a fixed point. So this fixed point is the fixed point is called center of the circle. And the constant distance is called radius of the circle. Like this is a circle. When you see, it is a collection of points. So many points are there. Here we have a fixed point O, whose distance from this each point is fixed. O is the fixed point, and there are so many points here like P1, P2, P3, P4, P5. All the points are lying on the boundary. So it is a collection. So many points are collected. All points have distance from a given point O is fixed. So that is known as radius. Moreover, you can also see in your lower classes some related terms to the circle like chord, segment, sector. Like chord, segment, sector. These words you have see in your lower classes, arc, etc. But in our syllabus we have to see some very important results that we want to see. Clear? Some important results regarding the circle we say. Let us consider a line PQ and a circle. So what will be the position in the plane if we are given a circle and a line? So different situations may be there. So there are possibilities. We have one line is given PQ and a circle is given. This may be position first, second position may be position in which PQ intersect circle at 2 points. point A and point B. At third position, it may be intersect at one point only, PQ, at point A. So different situation may be there. So this is very important in a plane when we are given one circle and one line. Different situations are there. Now first situation says the line and circle not intersecting. They have no common point because they have no common point. Or we can say line is not intersecting. Here you can say line intersecting circle, line intersecting circle at 2 points. So this is an intersecting line. The intersecting line is called secant. So this is the definition of the secant. What do you mean by a secant? A line which intersect the circle at 2 points. This point at A and at B. So the line intersecting the circle at 2 points. Clear? Similarly, in third position, line is intersecting at 1 point only. Line is intersecting the circle at 1 point. So this line is called as this line is called tangent. So there are only 3 possibilities which we see. If in a plane line has they may have no common point, they have 2 common points, then 1. So if line intersecting the circle at 2 points, it is called as an intersecting line secant. But when line is intersecting at 1 point, it is called as a tangent. Clear? So PQ have different name. Here PQ is called as a secant. Here PQ is called as a tangent. Clear? So you may have in daily life see so many problems where we have to see. Like you can say a pulley fitted over a bed, which is, as you know that in pulley, like this is a pulley, and here a rope is given to draw the water. Clear? We are. So this pulley, when rotated with the help of rope, so it does at only 1 point. So this is the example of the tangent. This rope work as a tangent to the wheel or pulley. So now you can say there is only these 3 positions when a line and circle are in plane. There is no other position. Only 3 positions are there. We cannot say other 4th position is there in plane we are given. So now we call this is our important topic in the circle. We are saying that is the tangent. Tangent to a circle. So what is the meaning of the tangent? A line which intersects circle at 1 point only. So if you want to write definition for the tangent, then one can write as tangent is a line. Tangent is a line which intersect or generally we call touch. Tangent is a line which intersect the circle at only one point. So tangent is always a line which is intersect or touch circle at only one point. So we may take different situation how we are saying this is touch at only one point. Like suppose if line is given and we take an activity with the help of that one, we can see. Suppose you take a circle and a line is given with intersecting circle at point B. Clear? So now if you are rotating this one at the point A, if we are rotating this line from the point A, means different situation may be there. Line may be like this after rotating. It may be like this, in this way. So there may be only one position where it touches at the one point. We may get different situation, but there is exact one line which will intersect the circle at one point, T dash. Other all are work as a secant, or you can rotate in this way, then again this will be intersected at two or more than points like this. So finally what we say that there is only one tangent at the point of the circle. So this point lies on the circle. We are drawing different chords, and there is one chord which is called as a tangent that passes through only one point. Clear? So we have doing this exercise, we observed that the position of this AB may be different, and common result is this, that tangent, like suppose initially this is a chord, or we can say it is a secant, because it is intersecting at the 2 points A and B. So whenever you are moving or you are rotating this chord or secant to different position, in this way this secant convert into tangent when it intersects a circle at only one point. So what we can say? We can say tangent to a circle is a special case. Tangent to a circle is a special case of secant. Tangent is a special case of a secant where the two endpoints of the corresponding chord coincide. Suppose we are saying this AB is a vertical secant, and this point A and B, when you take part is that is a chord. Chord is a part of secant. So when this point B moving in this way and coincide with A, this secant convert into tangent. That's why one can say that tangent to a circle is a special case of the secant when the two endpoints of its corresponding chords coincide. Clear? Now we take one more activity. Suppose we are drawing a chord passing through the center of a circle. Like suppose we take a circle. Here this is a circle and we are taking CQ as a secant. This is a secant which is passing through the point P and Q. Clear? So now we draw on paper this and various lines parallel to the secant. Now if we are drawing the different line parallel to the secant like this. So many parallel secants are there like this. Similarly here we draw different parallel secant to the given. So again you can see here there are two lines which work as a tangent. Like see this M A T dash T B T dash. So these are also tangent. So one can say this activity we can say that there are two parallel tangent to the given secant. So this also help us to see that there cannot be more than two tangent parallel to the given secant. We can draw two parallel secant to the given. So this is very important activity. Now based on this, here we can see one important result. So before that you see, here we call this is the point of contact. Point of contact. So what is the meaning of point of contact? The point at which tangent touch the circle. Point of contact means the point at which tangent touch the circle. Now we see the theorem. So theorem 10.1 says we want to know here the tangent at any point of the circle is perpendicular to the radius from the point of contact. So we prove here that tangent is perpendicular to the radius of the circle. So for that we have to see given as systematic we are saying first of all write given. So what we are given? We are given a circle whose center is O and radius is R. So given a circle COR. COR, C stands for center and O and radius R. And we are given tangent XY. Tangent XY to the circle at P. So here we are also given a tangent. This is X, Y at the point P. Clear? This is given. Now to prove, we want to prove the tangent at any point of circle is perpendicular to radius. So X, Y is perpendicular to radius, that is OP. equal to r. Now in proof we write, in proof we join OP. This point we have to join here, and take a point Q on XY outside the circle, Here you take the point Q and join OQ. Here we are taking a point Q that is other than P. In bracket you can write Q is other than point P. Clear? Now point will be outside the circle Y. We are saying that this point Q is lying outside the circle. As if Q lies inside the circle, suppose we take figure other, if point P here and Q is suppose inside this line and lie on this line, then this work as a secant. But we are given XY as a tangent. So as if Q lies inside the circle, then XY work as a secant, which is what? Which is not true. Why not true? Because we are already given XY is a tangent. That's why point Q lies. There are two conditions. If point Q lies on the XY, then it will be necessarily outside the circle. Because if Q lies on XY and inside the circle, then XY will work as a secant. But we are given already XY as a tangent. That's why this will lie outside the circle. And if it lies outside the circle, and you know that OQ is greater than OP. As you know that the distance of any point from the center outside the circle is greater than the distance lying the point on the boundary of the circle. So one can write OQ is greater than OP. Clear? Similarly, if you are taking any other point like this on this line, if we are taking some more point, then it is also true. Means if you are taking other points like Q other than P, then this happens for every point on the line XY. For other points it happens on XY except P. So what is the meaning of this? Similarly for other points it happens on XY except P. Means all points you may take. For example, you are taking here S, T, R or any. So again you say OS is OP or OT is greater than OP. It means what? It says that OP is the smallest line drawn from center to the tangent XY. And in previous class you already know that the shortest distance is called a perpendicular, and we know shortest distance is perpendicular. It means what? OP is perpendicular to XY, or you can say XY is perpendicular to OP. That is, XY is perpendicular to OP. Hence, tangent is perpendicular to the radius. So this is the proof of that theorem. Only we are writing the language. So important thing is there. Two things are there. First of all, you take point Q other than P on XY. So we can say OP is larger than, so OQ is larger than OP. Because if it's not true, then Q will lie inside the circle. Then XY work as a secant, which is not true. Secondly, you can take similarly all other points except you take any point on the XY whose distance from center is always greater than the distance of P from the center. That's why in all these lines which we are drawing from the center to the line, the smallest is the OP, that is radius. And you know in ninth class theorem, the smallest distance is always perpendicular. That's why this is perpendicular. Clear? Now we take some important questions regarding this topic. So by this theorem, one may be also conclude that any point on a circle there can be one and only one tangent can be drawn. Now question what says, how many tangents can a circle have? How many tangents can a circle have? So you can see, if we are given a circle, so how many tangents you can draw? Because there is no fixed point, and you know that on boundary of the circle there are infinite points, and you know for each point there is a tangent like this. Any point you can take. So how many tangents can be drawn? As the number of points, and you know that on the circle there are infinite points. So answer will be here infinite. How many tangents can a circle have? That is infinite. Now fill in the blanks. A tangent to circle, a tangent to a circle intersect, a tangent to a circle intersect it in how many points? In dash points. So we have already discussed a tangent to a circle intersect it in one only. Tangent intersects circle at one point. A line intersecting a circle, a line intersecting a circle at 2 points. If a line is intersecting a circle 2 points is chord. So that we already see, a line which is intersecting circle at 2 points, that is secant. So our answer will be secant. Similarly, a circle can have parallel tangent. A circle can have dash parallel tangent. Parallel So we already draw this type of a parallel tangent, that is 2. So two parallel tangent can be drawn to a circle. The common point of a tangent to a circle, the common point of a tangent to a circle, of a tangent to a circle, and the circle is called, that we have already seen definition. The common point of tangent and circle is called as the point of contact. Point of contact. So in this way we can easily find out these. Now next there are some practical activity. You can easily draw a circle and two parallel lines to given line. So that is, you can draw with the help of a construction. We are drawing a circle and then parallel line we draw. Clear? That for your homework. Two questions, question number 3rd and 4. Clear? That's all for today's class. For more, you should continue with us. We are taking some more theorem and exercise question in next videos. Thanks for watching. Have a nice day.